In this video, we will learn about Coulomb's law. First, we will introduce Coulomb's law in a basic way. Then, we will learn how to include vectors to account for the direction of the electric force. Finally, we will see how to apply Coulomb's law to more than two charges and find the net force on each charge. We will see all the equations in this topic, as well as 3D animation that will help us visualize everything more clearly. So let's get started. Coulomb's law deals with the force a point charge exerts on another point charge. A point charge is a charge that is so small that we can ignore its size at shape. For example, an electron is a point charge. A point charge has a polarity. It can be either positive or negative. Like charges repel, while unlike charges attract. The unit of electric charge is called the Coulomb. The mathematical expression for Coulomb's law is F equal K times Q1 times Q2 divided by R squared. K is the proportionality constant, which is equal to 9 times 10 to the power of 9 and has a unit of Newton meter squared per Coulomb squared. K is also equal to 1 over 4 pi epsilon naught. Epsilon naught is the permittivity of free space, which is equal to 8.854 times 10 to the power of negative 12. Q1 and Q2 are the charges in coulombs. R is the distance between the charges in meters, and the sign of the force tells us whether it is attractive or repulsive. Positive sign means it is repulsive, while negative sign means it is attractive. Now, what if we have two charges that are not on the same line? If we have two charges, Q1 and Q2, placed at different positions, given by the position vectors R1 and R2, then the vector R12 is the vector that points from Q1 to Q2, which is equal to R2 minus R1. And the unit vector AR12 is equal to R12 divided by its magnitude. Now F12 is equal to Q1, Q2 divided by 4 pi epsilon naught R squared times the unit vector AR12. Now we substitute AR12 equal R12 divided by R into F12, and we substitute R12 equal R2 minus R1 into F12. Now, if we have more than 2 point charges, we can find the force on any one of them using the principle of superposition. This principle says that the force on any charge is equal to the sum of the forces from all other charges. For example, if we have three charges, Q1, Q2, and Q at different positions, and we want to find the force on the charge Q, we just add the force from Q1 and the force from Q2. The same applies for any number of charges. To write this mathematically, if we have n charges Q1, Q2 up to Qn at different positions, lowercase r1, lowercase r2 up to lowercase rn, and we have another charge Q at position lowercase r. We want to find the total force F on the charge Q from all other charges. To do this, we need to find the force from all charges separately using Coulomb's law and add them together. This gives us F equal F1 plus F2 up to Fn. Let's try to find F1. To do this, we need to find the vector that points from Q1 to Q. We are going to call this vector uppercase R1, which is equal to lowercase r minus lowercase r1. The same thing goes for F2 up to Fn.